Okay, we're looking at question 4, exercise 11E. We're given a square, OABC, OABC. M is the midpoint of OA, so that's OM to AM are shared in equal proportion, so that's a 1 to 1, 1 to 1, because they're equal. And BC is divided by Q in the ratio 1 to 3. So that's the smaller side there. So that's 1 and that's going to be 3. AC and MQ meet at P. Now OA, let's put an arrow so we know we're traveling from O to A. It's given by A. That means C to B is also given by A. And OC is given by C, and that means that AB is also given by C. Let's put the arrow on there just to show which direction we're traveling in. Right, now because OA is given by A, OM is half of A, because it's M divides OA in ratio 1 to 1, so that's 1 over 2A, and MA is also a half of A. Now on this side we're going from C to B, so that means CQ is 3 plus 1, so it's a quarter of A, sorry, 3/4 of A even, and QB is a quarter of A. Total proportions are 4, that's 1/4, and that's 3/4. Right, express OP in terms of A and C. So express OP in terms of A and C. Well, first things first, let's look at this diagonal. It's running from A to C. So we can say that AC, the vector AC, is given by, if I want to go from A to C, I can also go from A to O to C. So I can go minus OA minus OA plus OC. So that's going to be equal to, oops, it's a vector, minus A plus C, which is equal to C minus A. Now let's look at the other line in the triangle. It's not a diagonal. It's MQ. So the vector MQ, I want to go from M to Q, so I can travel from M to A, and then A to B, and then B to Q. Which is negative QB. Tell you what, let's write it as negative QB. Negative QB. There we go. It's positive BQ but negative QB. Now if we put in the what they're given as, MA is half of A, plus AB is given as C, and QB, negative QB, so minus a quarter of A. If I combine the A's, half A take away a quarter of A is a quarter of A, plus C. So those are the lines that are running in the square. I want to find OP. So I'm trying to go from O here. It's not very good without a ruler, to P. So I want to find that vector OP in terms of A and C. Now I can travel to OP by going from O to A and then to P. So let's do that. We can say OP, vector OP, is equal to OA plus AP, but AP is along the diagonal AC. Now we know what AC is, but we don't know what ratio AP is as a proportion of AC. So we can write, let's use an unknown, let's call it lambda AC. So it's a fraction of AC. It's running along AC. So that's going to be OA is given by A plus lambda, and AC is given by C minus A from above. That means if we combine like terms, we've got A minus lambda A plus lambda C, which is given by A into 1 minus lambda plus lambda C. Now if we look here, another way of getting to OP, we travel OM and then MP. MP is along MQ, so it's a fraction of MQ. So we can write OP is given by OM plus a fraction of MQ, so let's call it mu. We don't know what it is. It's an unknown of MQ. OM is half of A plus mu, and MQ. MQ is from above, 1 over 4A plus C. So let's collect like terms. 1 over 2A plus a quarter mu A plus mu C, which is equal to, if we factorize, what can we take out? We can take out the A and let's leave everything else as it is. So we've got a half plus a quarter mu plus mu C. So we now have two values for OP. So we have OP here equals that term, and we have OP here equals that term. So we can equate them. OP is the same, so we can say that A brackets 1 minus lambda plus lambda C is equal to A brackets a half plus a quarter mu plus mu C. Now we can equate coefficients of A first. So that means if you look at A, what's next to A? That's its coefficient. So we can say 1 minus lambda, so 1, is equal to a half plus a quarter mu. Okay, and we can also then equate coefficients of C, and that's going to tell us that lambda is equal to mu. Now knowing that lambda equals mu, we can sub for that in this equation here. So instead of lambda there, I can call that mu. So if I say that's 1 minus mu, that means I'm going from 2 unknowns to 1, is equal to a half plus a quarter mu. So if we collect the mu's on the right hand side, collect the numbers on the other, that'll be 1 minus a half is equal to a quarter mu plus mu. So a half is equal to 5 over 4 mu. That implies then that mu is equal to 4 over 10 or 2 over 5. So mu equals 2/5. that implies that lambda equals 2/5. So if we sub it, let's see which one looks like the easier equation for OP. I'd say this one here. So if we sub it in that equation, we've got OP, doesn't matter which one because OP is OP, is equal to A brackets 1 minus lambda. That's 1 minus lambda plus lambda C. So that's going to be equal to A into 1 minus 2/5 plus 2/5 of C. 1 minus 2/5 is 3/5, so that's going to be 3/5 of A plus 2/5 of C, and that is absolutely perfect because it divides it then in the ratio of 3:2. Marvelous. To show the ratio, work out, just work out AP. AP, that's going to be equal to, to go from A to P, you can go negative OA plus OP, negative OA plus OP, these are vectors, equals OP minus OA, and then you just put in the vectors. You've got OP now, which is 3/5 of A plus 2/5 of C minus OA, so minus A, and when you work that out it gives you 2/5 of C minus 2/5 of A equals 2/5 of C minus A, which is marvelous. And that is, so if we look up here, AC is C minus A, so AP is 2/5 of that, which means you're left with 3/5 for the rest of it. So it's a ratio of 2 to 3. Job done.